Welcome to How Do We Know What's True? Today's question, do vaccines cause autism? This is a claim I'm sure most of us have heard on the internet, and we're going to break down how do we know if that's true without becoming an expert in autism or vaccines ourselves, which I am neither. But I am an expert in logical thinking. I'm a mathematician. So I'm going to go through how I reason through information on the internet or in other sources of media and try to figure out what's actually true. So let's get into it. The two main arguments I hear about vaccines causing autism is there are higher rates than ever is number one. And number two is I know somebody. Okay, so a personal story. Okay, so those are the two main things I hear. So the first one, higher rates. So you may have heard this before if you've taken a statistics course, but what the general rule is, what we consider to be true is that correlation does not mean causality. So if you've never taken statistics, that's okay. If you took it and you don't remember that, that's also okay. And if you took it and you didn't understand it, that's also okay. So what does this basically mean? It means that just because two things are going up does not mean one is causing the other. Okay, so yes, we see higher rates of autism today than ever. We also see higher costs of, say, housing has also gone up. It's skyrocketing. We also see more people identifying as LGBTQ. And so, and then we also see the higher rates of autism. We see more vaccines being distributed as well. So, just because multiple things are moving in the upward direction over time does not mean one is causing the other. We wouldn't say, well, the cost of housing is going up. That must be what's causing the autism rates to go up. No, that doesn't make sense, right? Okay, so there's got to be a way to figure out when something is causing something, right? So just because, and by the way, the official answer for both the vaccines and the autism are we have better science. So we are better at detecting autism. It's not that more people are autistic. It's that we're testing more, we're identifying it more. It's sort of like, if you gave everybody a flu test, you're going to find out more people have the flu than you knew about before you tested everybody. Okay, so we're better at detecting autism now. That's why there's higher rates. More vaccines also, we have better science, right? As science gets better and better, we can end up creating more and more vaccines and hopefully eradicating more and more unnecessary illnesses. Okay, and we'll get into more about how those decisions are made in this video as well. All right, so there's got to be some way to figure out if there is something causing something, right? We should be able to claim that. So if correlation does not equal causality, then how do we determine when something is causing something? Well, the way we do that is with studies and statistics. Okay, so, and who does what? So how does that actually happen? We'll go into on a different video. I'll go into what it means to be statistically true and a little bit of the math behind that. But basically, there's some mathematics that goes into it, but we can figure out what the probability of the coincidence is, if that makes sense. So, for example, let's say we're testing a medication and we have 100 sick people. We give 50 the medication and we give 50 we don't give the medication to. Well, then let's say 49 of the 50 feel better that got the medication. Is that a coincidence? Well, what if it's only 5? Is that, maybe they got better for some other reason? So at some magic number in there, we can say, yeah, that's probably was the medication that, or we can be 95% sure. But that's the important thing about a lot of statistical truths is there's a percent probability of how true it is. It's not 100% absolute true, and that's something important to distinguish. Okay, so we do studies. So experts in whatever it is, it could be autism rates, it could be, you know, anything, medication, it could be, you know, best practice in teaching, and, you know, what's the most effective way to do something in a classroom. So somebody goes out and collects the data, and it might be a teacher in a room collecting data on students. It might be which is basically our grading system, right? We're collecting data to see how well students are doing on standardized tests, things like that. We collect data from patients. We're always collecting data. That's really what scientists and researchers are doing, is they're out collecting data, right? We're digging up dinosaur bones. That's more data for us to get into. Usually the person who does the data analysis is a mathematician or a statistician like myself, somebody trained in the data sciences. So those are two kind of different expertise. One person, usually some sort of scientist, is going to do this, is going to collect the data and do, you know, maybe it's a psychologist who's talking to their patients, or a doctor, something like that. And the person who's going to run the data and find out what's the probability of this being a coincidence or what's it being actual causing something is some sort of math nerd. Okay, so that's who's going to do that. So just so you know, those are two separate things. So it's not like one person can, you know, usually just lie about this stuff too easily. Okay, so that's how we figure out causation. We do studies and we do statistics. So the evil scientists might be lying when they're collecting their data, but the mathematicians who you can trust, like myself, we are going to check the numbers and we're going to verify it. And other scientists are going to try to collect more data, and we're going to verify across the board that everyone's getting the same results. That's called verifiable science, and it's reproducible, you know, like building an airplane. We know how planes fly. It's not a theory anymore. It was at one point, but it's such good science now that it's just reproducible. You know, any company can, you know, with basic engineers, can go out and build a plane. Okay, so those type of things we consider to be, you know, solid science and good science. Okay, so say you don't believe studies. Say you're somebody who says, yeah, I'm not really sure. I don't trust these scientists. Maybe you mathematicians are on the level, but I think they're giving you bad data. I think they're all in on it, you know, on whatever it is with these vaccines. And let's get into like what it means to actually say these vaccines are unsafe. So, case one, okay, the medical community they know they're bad for us. Okay, and then case two, they just got it wrong. Okay, so there's a difference between lying and being wrong. So that's something to keep in mind when analyzing information, and maybe you don't trust the source, maybe you don't trust the media, maybe you don't trust science, but you know, you want to ask yourself, well, are they intentionally lying, or are they just getting it wrong? So the intentional lying across an entire industry is a very irrational conspiracy. You might not know scientists, or might not know people in the medical community, but let's say you know some hobby mechanics that work on cars. And let's say somebody told you that all the mechanics in the world, all of them are lying and saying you need these oil changes, and they're just trying to get money out of you, and you don't actually have to change the oil in your car at all. It'll be fine. Just don't do it. It's going to be fine. It's all just a big conspiracy to get money out of us. But you know cars. Maybe you know cars personally, or somebody you know works on cars, and they know, and they're telling you, and so you trust them, and so it doesn't make sense. But if you don't know scientists, or you don't know doctors personally, you might be able to easily characterize, you know, somebody based on their occupation as, oh, they're all out for bad, or, you know, some evil nefarious intention. So that really doesn't make a lot of sense any more than it does like all mechanics. So we're talking about, you know, multiple countries, multiple states, multiple cities, multiple you know, governments. It's just too big of a conspiracy. And what I mean by that, and what the mathematical part comes in, is what's the probability of like that not coming to light? A big conspiracy where a bunch of people are lying. And I'll give you a scenario. Let's say you work somewhere. It could be a store, it could be an office, could be a scientist, and your boss, or maybe you're a construction builder, your boss asks you to do something obviously illegal. Maybe take a little inventory, go put it in their car. Skip a few safety codes while building this building. Lie about the data on your report. Wink, wink, don't tell anybody, but do this for me. That probably happens. But what's harder to imagine happening is the boss standing up at a meeting with like 20 people in a room saying, we're all going to start stealing inventory. We're all going to start lying about our data. We're all going to start skipping business, building codes and safety regulations, and we're just going to cut through because we got to maximize profit. Announcing, something illegal or nefarious in a large group is high risk. People don't crime together well. Okay, they don't break the rules together because there's a higher chance somebody's going to stand up and go, whoa, 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 I'm not comfortable with this, or somebody's going to tell, or somebody's going to whistle blow. And so the idea of it happening in a room of 20 people seems odd, let alone across all companies, all scientists, right? All mechanics, like they're all going to go in on this nefarious plan. It's just too big to be realistic. So that doesn't make sense. So there's no reason for the medical community to be lying to us on purpose, trying to poison us for what? To make sure there's more autistic people in the world. It doesn't make sense. Usually the motive is where it'll definitely fall apart, but it's just too big. It's just too big to be true. So case one is not true. The medical community is not intentionally lying to us in some nefarious way. Across the board where everybody knows about it. Now, maybe they just got it wrong. Maybe the vaccine companies are out for profit, right? And they did all do something evil, but they fed bad information to your good doctors who you do trust, and that's where the bad information is coming from because they're all funded by evil people and stuff. Well, that might be true. So, but there are nonprofits and other people who, again, can verify this information. So it's not like everyone just trusts one study from the company that makes the vaccines. So it wouldn't just be one person got it wrong. It would be a lot of people got it wrong. So you can go online and you can search, do vaccines cause autism? What does the science say? And you can find some scholarly articles. And basically there's a bunch of research done. I looked some up earlier today. There's a lot of articles with a lot of names on them. Again, it's across universities, it's across nonprofits, it's across countries internationally where people have agreed scientifically that this isn't the case. If they thought that was the case, they wouldn't be, obviously continuing to use these vaccines if they thought they were causing some adverse effect in society. So it's not possible for a bunch of folks to be nefarious together, but what's the probability that all scientists got it wrong? Well, that's the reason scientists check other people's work, and multiple people try to reproduce this work, and multiple people do studies, and there are multiple studies on this subject. So what's the likelihood, probability-wise, that they all got it wrong? Not likely. So this is also just not going to be true. It's very unlikely to be true that all of the medical community is lying, or that all of the medical community got it wrong. Okay, so if you don't know how to read scholarly articles, what I recommend is reading the abstract, then the introduction and the conclusion, maybe looking for some charts to look through. But most academic articles are going to be above our understanding if we're not experts in that field ourselves. But as a layman, we can come in, we can read the abstract, the introduction, conclusion, look up, whatever terms you want to look up as much as you want to understand that study. But there are multiple studies on this topic. So it's either we're saying they all got it wrong, or they all are lying. Both highly improbable. Okay, so, but here's where we're going to go next. Let's say there was a vaccine that caused an adverse effect. Let's just say, as a benefit of the doubt, let's just give that some ingredients. So let's say a vaccine is going to cause something bad, but not lethal. Okay, so, and let's say that's going to happen to 10% of the people who get the vaccine. Now, when we say vaccines cause autism, if you were going to do a study on that, you need to be very precise with science and logical and reasoning, and when you think through these things. Which vaccine? Is it the combination of a bunch? Is it the timing? Is it, a particular one? That's what you'd have to set your study up in order to answer a very specific question. Okay, so one vaccine I was surprised about with my own kids was the chickenpox vaccine. I had chickenpox as a kid. Didn't seem that bad. I remember I got to miss a bunch of school. I was itchy as heck. It was uncomfortable, but, kind of felt like a rite of passage because everyone got the chickenpox is what we were told. So I was like, a chickenpox vaccine? That doesn't seem that important, it didn't seem that bad. So I looked it up, and it turned out like some number of kids died every year from chickenpox. I think it was 100, maybe 200, maybe 50, something like that. But some number of kids. So let's say that without a vaccine, there's going to be some amount of death. And let's say it's just 1%. Then the question is, do we distribute the vaccine to the population to reach herd immunity? And if you don't know what that means, you should definitely look into herd immunity and find out how that works. Again, more math behind that, where we figure out exactly what percentage of people in the population need to be vaccinated to get herd immunity, which means basically you're not going to see any cases anymore. So let's say it's 80%. Okay, we need 80% of the people in the population to be vaccinated in order to eradicate chickenpox. But let's say if we do that, 10% of the people who get that vaccination, so 10% of the 80%, so it's 8% of the population, is going to have some adverse effect. Maybe it's autism, maybe it's a patch of white hair, whatever it is, something non-lethal, but maybe not something great. Do you distribute the vaccine knowing that's going to happen to 10% of the population, but it's going to save the life of 1% of the population? That's a hard decision to make. That's not really the role of science. That's the role of government and regulations and people who run society and have to decide what is the pros and cons of each. Now, if you come from a family where you knew somebody that died of chickenpox, you're probably going to want to be pro-vaccine. You don't want that to happen to another family. If you're one of the people who got a side effect from the vaccine, you're probably going to say, hey, I'm in the 10% of people that were affected by this. I don't like it. The short answer is nothing's going to make everybody happy. Nothing's going to make everything perfect. But somebody has to make that decision, and that's where the reasonable, rational thinking goes into really decision making. I wouldn't want to make that decision. I don't want to judge anybody that does have to make that decision. It's a hard decision. But that's really the question is, where the question comes down to the role of government. So somebody had said to me, well, there's plenty of evidence to show that, these vaccines are having adverse effects. Okay, so again, let's just say that's a given true. Again, the science and the studies indicate that that's not. We've already talked about, the chance of that being wrong. But let's just say for the sake of argument that it was true. What is the government supposed to do about it? We have research showing that cigarettes are bad for us, and soda, or too much red meat. But when you start banning soda, or red meat, or alcohol, or cigarettes, suddenly it's a nanny state, and it's taking away your freedoms, and you have the right to put all this bad stuff in your body and live the way you want, and smoke a cigar and eat a steak, and that's your choice, right, to put those toxins into your body. But with the vaccine, we also have the right, to put those toxins into our body, but it doesn't feel quite as, free for some reason. Well, that's because society has to decide, do we mandate these vaccines for things like public spaces, public education, where if we need that 80% to be vaccinated, then yes, we do, right? That we decide you can't come to the schools unless you have that. Okay. So those are the tough decisions that people who run society need to make. But should anybody be forced to take them, to be forced to put anything in their body? Probably not. It's that I know of, nobody has been. Look at the idea of cigarettes. When we have research showing cigarettes are bad, question is, do we put an age limit? Do we put propaganda out to show how dangerous cigarettes are? Do we pay for, informing and educating the public on the dangers? Is that what we should be doing about vaccines? Should we be putting warning labels on them? Should doctors be required to give you some sort of warning label? If there was science supporting that there's a risk, but, and give you that choice and say, look, you can either take the 10% chance of having this adverse effect or this 1% chance. If you don't take it, you have this 1% chance of dying. If that's up to each individual, that's fine. But then we don't reach our herd immunity numbers if we don't mandate it. So it's not really an individual choice. And when you think about smoking, it not only hurts yourself, it hurts people around you, and so you aren't allowed to do that in public spaces. For the same reason you can't walk into public spaces unvaccinated, you could harm somebody else. So do vaccines cause autism? The science says no. And we have to trust the scientists because, they're the experts in the field. It doesn't mean that they're right. Science is wrong sometimes, but it's the best guess based on evidence, just like a court system works, right? We don't absolutely know every single person is beyond a doubt guilty, but we look at the evidence and we make our best guess, and then we make a decision based off that. We make a decision whether that person goes to prison or not. Same thing with science. We look at the best evidence. We see, we have people dying of this and this vaccine that we've tested and it seems to be safe or, somewhat safe or whatever the case is, then someone has to make a decision. Do we distribute it to the population? Do we offer it? Do we mandate it? Do we recommend it medically? And that's what it really comes down to. No one can say, outside of really mathematics, what is absolutely true. We can just say what's probably true based on the evidence, based on the statistics, based on the data, and everyone just has to make their best guess or best decision based off that information. So that's how you reason through information questions, how I would take a look at the question, do vaccines cause autism? The science says no, and I'm going to trust the science. Thanks for watching.